Yeah, I know we've already talked about this to a point, but I need to go over it again to make sure you understand all the different things within constraining an assembly. Okay, so an assembly constraints are parameters that define geometric relations between components and the CAD assembly. Like dimensions are a constraint. It says it can't get any bigger than that or any smaller than that. Now, inside Inventor, the assemblies, there's these different types of constraints. Now, in Onshape, there are different, the constraints are very similar, but they're done a little differently. And I already talked about that in the video that you can see with this assignment. So there's the mate and the flush. There's mate and flush together. You just change which one you want when you get in that tab. There's the angle constraint, there's the tangent constraint, and then there's the insert constraint. First thing you got to understand with all constraints, anything, any program, any 3D modeling program when you're doing assemblies, is there's 6 different types of degrees of freedom. Okay, there's the rotationary one. So if it rotates this way, it can rotate this way here, and it can rotate this way here. There's 3 different ways it can rotate. There's also 3 different ways it can go in the X, Y, Z location. So it can go like this, it can go up and down, and then go right and left. Okay, so there's 6 different types of degrees of freedom that you need to get rid of in order to keep it in a stationary position. Okay, so when the first part we bring in, we talk about grounding. When you ground it, you're getting rid of all 6 degrees of freedom. Okay, so the degrees of freedom are systematically removed in an assembly until the only desired degree of freedom is still allowed to move. So if I have an axle going in, but I still want it to rotate like this, I'll get rid of 5 of the degrees of freedom, but I'll leave this degree of freedom available for it to rotate. If I have a part that I want to move down like this, I might get rid of a rotationary degree of freedom for that as well. Okay. First, let's talk about the mate constraint. Okay, the mate constraint, Onshape has that as well. You saw there's 3 different ones, I think it was, or 2 different ones. But the constraints 2 faces or edges together. So I can actually put the edge of something together, or I can do the whole face and put them together. Okay. The red arrows in this example here. I'm just gonna get my mouse here. There it is. So this example here, you can see those red arrows showing the direction. So this is going to go mating to that part right there, that face right there. You can see here's this face is mated to the one on the other side of it. Okay. Flush constraint. Flush constraints are different. Flush constraints say that if I want to make something this side of my hand flush this side of the hand. Okay, that way it can go like this, but it's not putting them together. Okay, it's just putting them left and right. Does that make sense? Hopefully it does. So with the flush constraints, 2 faces or work features together, normal vectors will point in the same direction. So you can see how this one's pointing, these 2 down here are pointing in that direction down. Then this surface and this surface will be flush next to each other, so it can't go down or above that. Okay. Angle constraint constrains 2 faces on whatever specific angle you do. So in this case, we did this face here and this face, then we give it an angle of whatever that is, maybe a 30-degree angle, and that's the angle that it went off of. Okay. Normal vectors parallel to each other is actually a 0-degree angle. So if I want to go a different angle, I'd have to change that angle. Okay. Insert constraint. You would use this a lot with your Automoblocks car. Okay, so whenever you go put in a circle into something, what that does, it allows the center point of this item here to be constrained to the center point of that way, and I can then put this face down in this area here, so it's inside there, but it can still rotate. That's what the insert command allows it to still continue to rotate. This case, you can see if you look at this one down here, this one right here, you can see that the outside face, this outside face here, this outside area was with this one. That's why it's sticking above it. Okay. The tangent constraint allows you to constrain a curved surface, maybe a curved surface with a flat surface or a curved surface with another curved surface. And that's what we're doing here. This surface to that surface. Okay. You can see how it's done right there. Okay. Your base component, that first component that you bring into an assembly, should be it should be the main fundamental part of it, or possibly a subassembly, a frame, a base plate, something like that. The first component in the assembly file sets orientation. So if I want to set this here and I want to set this as my front view here, I want to set it up like that. But then what I need to do is I need to do what's called ground that That part is the only part that's going to be grounded. Once that's grounded, everything else is going to be assembled to that part. Okay. So when the first component is placed in the assembly, its original is coincidental and assigned with the assembly coordinate origin. Okay, so I set it up how I want it set. Then when I ground it, it gets rid of all degrees of freedom. So it will sit there. I can't move it. I can't do anything to it. It's going to stay there. So if I constrain something to it, the other thing is going to constrain to it. It's not going to constrain to the other thing. Does that make sense? The base component will be grounded and it should be left that way. So if I come in here and I right-click on what component. In this case, we want to right-click on that component there, and then I choose grounded. There's a grounded thing. A little check mark will appear by the grounded, and that tells you that that part is grounded and it will not move. Okay. Patterning components, function duplicates, one or more components. It also arranges the results occurrence in a circular or rectangular pattern. So it allows you to put it in a pattern. Replacing the component, you can actually go into the assembly, right mouse click on a component or a part, and say replace the component, and then you can actually choose which component you want to put in there instead. A new component will replace that one. Editing a component, if you double click on the component inside the assembly, it will actually gray out all the other ones. We've already seen this, and then just allow you to work on that one. And then when I hit the return button in the upper right corner, it'll bring it back. It didn't save it, and that's why when you hit save for the assembly, it says, do you want to save these other parts, the change you made, the parts, you always say yes to all. Okay, so if you, like it says, become translucent or grayed out. When you finish editing the part, you exit the part environment. Sometimes I like to save it inside the part. You can still save it inside there too, or save it later. Sub-assemblies, that's an assembly within an assembly. In this case, this one here, you can see you've got the assembly symbol there, shows you that's an assembly. These two assemblies, this one here and the rack one here, those are assemblies within my Arbor Press assembly. Does that make sense? So I can have assemblies and have smaller assemblies put inside. So like with your automobile blocks, you might want to have the wheel assembly with the wheel and tire already on it before you bring it into the actual automobile blocks assembly. And that would be it for this one. Okay, so hopefully you understand the 6 different degrees of freedom and how many there are and what they are, because that's important to understand. And then the different types of constraints inside Inventor, and basically inside all 3D modeling software, it will have those 3 different types, or those different types of constraints made insert. But sometimes they do them just in different ways, you can see on the Onshape. But hopefully you can figure it out. I will say Inventor is a lot easier to constrain things than from Onshape that I've noticed, but you can definitely do it. Just took me a little longer to figure out how to do it on Onshape to show you and demonstrate that. All right, that's all.